parameter xc, but right now we have three coefficients, x0, x1, x2. So in total, we have like three times numbers of the coefficients that we had before for the front camera. So originally we have 6, and right now we have 18. So we have 18 parameters to describe the EOP behavior. Okay. So that's the things we talk about, and this is what we talk about in the first class. So well, in the lecture we talk about it in the chapter 9. So this is my, I don't know, I intend to show you guys the most important thing at the beginning. So that's my way of teaching. So but just different people have different style. Alright, so basically these are the three main, well, you can say participants in the imaging geometry: EOP, image coordinate, ground coordinate, or object space coordinate. So as long as you know two of them, then you can derive the other one. So space resection, space intersection, image reprojection. So to derive the EOP, to derive the object space coordinate, or to derive the image coordinate. So those are the locations, the main locations in photogrammetry, or the usage of the coordinate condition equation. So, and here is talking about what space resection is. I'm not going to dig into the detail, and I believe you guys know it already. For example, something that you may not so familiar with could be the degree of freedom, you can say. We talked about it before, actually. For example, for each of the control points, you can have two equations. So we need if we have k GCPs, then we have 2k observation equation, and alone is 6. So which means that we need at least 3 control points to solve the EOPs. And that's something you know already. But as you can see, if for a linear array, for the Wishbone scatter, and we have 18 coefficients in terms of for the EOP. So in each of the GCP, we can have 2 equations. So to solve 18 coefficients, we need at least 9 GCPs. So basically that's the case. Okay. Okay, so here is about the automatic orientation determination. This is a little bit, this is something that I didn't focus on enough, actually. So pay attention here. In order to perform the orientation modeling automatically, there are 2 types of ways. So the purpose is to obtain where you are taking the photo, and then what is the angle that you are using for the photo. So there are 2 possible ways to do it. One is directly use the GPS and INS that you have from your imaging system, from your camera system. You directly use that. So what exactly does that mean? That means that I believe we talked about this term before, the direct georeferencing. Did we? Did we talk about that?
Yes, we do.
Yes. Okay, that's good. This is in Chinese. It's called 直接地理定位. Alright, it's 直接地理定位. Okay, so basically, which means that you can have some sensors in your whole imaging system, and then especially you need to have GNSS to know where you are, and INS or IMU to know what's the rotation angle. And I believe who choose the mobile mapping paper? Okay, so so Zhenyong will tell us about this is, as you can see, this is the whole mapping system. And you will have, for example, like the GPS sensor or GNSS sensor over there, and you may have an IMU to know your rotation. But however, your camera is over here. So they are at different location, and then their coordinate system may be different. So how to integrate those things, everything together, so that they all follow the absolute coordinate system in the image space. That is the important procedure in the mapping system construction, or in Zhenyong's paper is the mobile mapping system construction. So as you can see, if you have a surveying car like the Google Street View car, it has the GPS sensor, it has an IMU sensor, and you have some camera system. But however, how the GPS location is over here, camera is over there, and then you have the IMU, which indicates your rotation angle is like in this in this coordinate system, but your camera is following its own rotation, following its own coordinate system. So how to transform and how to register them together to the the real world coordinate system, the object-based coordinate system, is the most important thing in constructing such mobile mapping system. Okay, so is also a requirement for your presentation as well, because in that paper they only took like half of the page to talk about that. But however, I hope you can talk about it more clearly, because that's something I care. Okay, that's something I care. So it's a requirement for you. Alright, so Zhenyong will tell us more about the direct georeferencing in terms of the mobile mapping system. So what I'm trying to say is direct georeferencing means that you directly use the XC, YC, ZC, omega phi kappa you derive from the sensor, and also of course with some transformation in the mobile mapping system. Okay, you directly use that. But as you can imagine, if you directly use those sensor readings, and we talk about, say, those sensors, they contain arrows. They contain arrows. So it doesn't matter it's in the location or orientation, it contains some arrow. So if you directly use that, then your positioning also have some arrow. Let's just say, I believe I talked about it before, but just to refresh your memory. If you are talking about the satellites, the optical satellites, for example, for the worldview series, the worldview series satellite, their direct georeferencing arrow is about less than 10 meters. So it's pretty good. Actually, it's pretty good. Let me give you another example, which is the Formoset 2. The Formoset 5 is another story. Formoset 2. Formoset 2, at the beginning or after it launched, the direct georeferencing arrow is about what I remember, based on my understanding, is about tens kilometer away from the real target. So it's really far away from where you're looking at. So but gradually they refine the, as you can see, there's a lot of coordinate transformation here. So they gradually refine it to reduce the positioning arrow, and at the end, I believe it becomes less than 1 kilometer, but still has a few hundred kilometers direct georeferencing arrow. Okay, so that's the type of arrow that you will get if you directly charge you can say the EOP information from the satellite. Okay, so that could be the arrow that you have. So which indicates that if in the future, after you get the raw image, supposedly you cannot directly use it. For all the cases, at least you need to perform the auto-relocation to correct it, to perform the geometric correction, and then you can use that for the GIS applications. Okay, so how to refine it? How to refine it is the next step. So this is something that I probably didn't mention clearly before. It's still about how to automatically perform the orientation modeling. But this part is by using the GCP database, the control points database. In Chinese, it's 控制点资料库, right? 地面控制点资料库. So there are some, you could have some GCP database. They are usually important. They are usually kind of not, well, how to say it? You probably need to, because the maintenance of the GCP database is costly. It's pretty costly because once a while you need to go there and then to measure the real or the corrected object-based coordinates again and again. So you need to maintain it. So it's pretty costly. And you need to also protect it a little bit. For example, if you want to let the satellite to see it, you need to have a certain size. And I believe last time I drew something like this before. Sometimes on the ground, you will see something like this. Well, quite huge one actually. Sometimes on the ground you will see something like this. These are the white, like this part are kind of, they draw it as the white color. So this is called, this is actually the control point for the aerial photogrammetry. You could use that for the satellite as well, but your resolution needs to be high enough. Okay, so basically you can after you take the photo, then you can recognize this feature on your image. Then because you will you will do some control surveying to know the object space coordinates of this point. So after you recognize this feature on the image, then you can measure the matched image coordinate as well. So you have the control points, the matched ground control, the object space coordinates and the image space coordinates, and you have your control points. So that's what you can do. And what I'm trying to say is it requires some maintenance. So, and in terms of the GCP database, usually the content includes the ground control, the ground coordinates, and also the image clip, image chip, or a small clip of that control point, and some description of that GCP, of that control point as well. So the important thing is about the image clip. Okay, so basically, this, as you can imagine, what's the reason that we need this? Is because sometimes we want to perform to find, like I said, after you take the photo and covers the control point, then you can go to your image and find that feature and measure the image coordinates. And that takes time if you do it manually. So the reason that we have the image chip is because we know what's the appearance of that control point. It's a small image, and we know that appearance, and we can use that to perform the image matching with the new image that you have. So we have a small image clip chip, and then you have the whole image. And right now you want to find where that is on your image. So with that information, you can perform the image matching, and then try to find out where that is. Okay, so it becomes a more automatic process, and to reduce the labor loading. Okay, so that's about this. And for the airborne data or satellite data, then you have your initial EOE. The navigation data means the initial EOE, and you have your image. And the initial EOE allows you to perform some prediction. So what you can do is you can reproject the ground control point, the ground coordinates to the image. So you have a certain range. It's kind of like the director referencing, but however, because it has some error, so you need to enlarge the search area. So, but however, this is one way to search for it. And then after you have that, then you have the image chip of the GCP, and then you can perform the image matching to find that find that coordinate, find that control point on the image more precisely. And then you have your GCP, and you can perform the orientation determination by using the space resection. Okay, so that's the whole procedure. Right, that's the whole procedure. Right, can you guys understand about the prediction and the matching part? No? Yes? All right, let me kind of repeat it again over here very quickly. Right now the problem is, what the procedure means that right now you have the image. You have the image, and then, and also here. Okay, here is you have this. Alright, so right, supposedly this is the ground control points that you have, the GCP that you have, and we right now the problem is that the EOP that we have some error. So so here you could have the ideal EOP, the correct EOP is over here. But however, you may have the AOP move to another place and with another probably another tilt angle. So in this case, in order to refine the EOP, what you can do is you want to find the GCP, the matched image point on the matched point on the image. So as you can see, the first thing is about the projection. What we can do is we can reproject this point with the current, the initial EOP that contains error. So supposedly, originally, ideally, the GCP should be over here. Ideally, the GCP should be over here. But however, after you use the directional referencing, when you reproject it, it may becomes over here. Right? It may becomes over here for many reasons. Maybe the error in the GPS or error in the INU. So in this case, you couldn't directly trust this location, of course. So with this, you can create a certain search region. You can create the certain search window, and that's the prediction. That means the prediction, right? So after you have that, because each GCP, it contains each GCP, it contains a small image that, for example, look like this. For example, just for example, right? You have something like this, right? And then with this, image shape, then you can match that here.